In this segment, we will discuss acceleration. We define acceleration as the change in velocity as a function of time. In terms of a formula, it's final velocity minus initial velocity. That's the change in velocity over time. That's what we define as acceleration. Again, it's a vector. It has a magnitude and a direction. Its units, the unit for velocity is meters per second, and we divide that per second, so it's meters per second square, or meters per second per second. Okay, again, final velocity minus initial velocity over time, and direction is important. Now, what causes an acceleration? How can we get an acceleration? Whenever there is an increase in the speed, a decrease in the speed, or a change in the direction of the velocity. All three will result in an acceleration. Okay, this is especially new. For example, if you are in a car, you are actually accelerating even when you steer your car, even when you are moving at a constant speed. An object moving in a constant speed in a circle is actually accelerating because the direction of the velocity is changing. What else is new is the fact that both an increase in speed and a decrease in speed are actual accelerations. Unlike what we use in common day language and think of accelerating when we speed up and braking when we slow down. In both cases, we say we are accelerating. You might see in the literature some people using the word deceleration. I personally don't like the word. It is not necessary. And we'll see later on, it can cause a little bit of confusion if we are not careful on the way we are using it. Saying we use an acceleration for both speeding up and slowing down, for both speeding up or slowing down, or changing direction, or the combination of both, of two of the above, it's quite sufficient. Now, what causes an acceleration? And we'll get back to this a little later on. An unbalanced force. That's where we stopped. In Newton's first law, we said an object moving at a constant velocity or an object at rest will stay at rest unless acted on by an unbalanced force. So if we have an unbalanced force, a net force or a resultant, remember all of these are the same name for the unbalanced force, then we have an acceleration. In a car, what are the devices that we can use to accelerate? The accelerator pedal, that's speeding up, brake pedal, that's slowing down, steering wheel. Whenever you change speed or direction, you accelerate. You can do two of these at the same time as well, resulting in an acceleration. Now, let's take this velocity versus time graph that we had before, and let's use the information that we have here to find the change in velocity between t equals 3 seconds and 5 seconds. And then from there, find the average acceleration during that time. Okay, change in velocity at t equals 3 seconds. Okay, that's 3 seconds. My velocity is 3 meters per second. So v at 3 seconds is 3 meters per second. At t equals 5 seconds, v at 5 seconds is minus 2 meters per second. My change in velocity is then minus 2 meters per second minus 3 meters per second, which is minus 5 meters per second. Now my average acceleration is change in velocity. Notice the symbol I'm using, this delta V. Delta V means V final minus V initial, or change in velocity. So change in velocity over time. So that's going to be minus 5 meters per second over 5 seconds minus 3 seconds. So minus 5 meter per second over 2 seconds. So it's minus 2.5 meter per second squared. That's my average acceleration between these two times. If the velocity of some object is not zero, can the acceleration be zero? Of course, try to remember Newton's first law. An object in motion at a constant speed in the same direction will continue with that same motion at that same constant speed. That's an object moving at a constant velocity. Constant velocity meaning the acceleration is zero. So yes. Is it possible for an object to have a positive velocity and at the same time a negative acceleration? Okay, now this is going to be a little tricky and we need to pay attention to it. Let's take some examples. A car moving in the positive direction at plus 10 meters per second. Let's say at time t equal 1 second. 2 seconds later, it's moving at plus 20 meters per second. So 2 seconds later, that's t equals 3 seconds. What's the acceleration here? Acceleration, change in velocity, so plus 20 meters per second minus 10 meters per second over the time difference, 2 seconds. So 20 minus 10, 10 over 2, so it's 5 meters per second squared, plus 5 meters per second squared. Okay? So I now have positive velocities, positive beginning velocity, initial velocity, positive final velocity, and a positive acceleration. Now, let's take another example here. Car moving at 20 meters per second plus 20 meters per second at t equal 1 second. 2 seconds later, it's moving at 10 meters per second. What's the acceleration then? Acceleration is going to be 10 meters per second minus 20 meters per second over 2 seconds. It's minus 5 meters per second squared. Now here, my acceleration is negative. Even though both my velocities are positive, my acceleration is negative. Now, the negative acceleration here is telling me that I'm slowing down when my velocity is positive. But the answer is not as simple as this. We have to be careful. A negative acceleration does not always mean that we are slowing down. A case in point. Let's assume we have a car moving in this direction at 10 meters per second. at t equal 1 second. And then at t equal 3 seconds, it is moving at 20 meters per second this way. Now, what is the acceleration in this case? We are going to use the same analysis. Acceleration is final velocity, but it is in the negative direction here, so it's going to be minus 20 meters per second. Minus initial velocity. Initial velocity is also minus 10 meters per second. So it's minus 10 over 2 seconds. So it's going to be minus 10 plus 10. So it's going to be minus 10. So it's going to be minus 5 meters per second squared. So in this particular case, we have negative velocities and negative acceleration. When my velocity is negative, a negative acceleration is telling me that I'm speeding up. When my velocity is positive, a negative acceleration is telling me that I'm slowing down. When my velocity is positive, a positive acceleration is telling me that I'm speeding up. Of course, the last case, what's going to happen if I'm slowing down in the negative direction? What if I start at 20 meters per second and get down to 10 meters per second? Now my acceleration is going to be minus 10 meters per second minus 20 meters per second over the 2 seconds. And in this case, it's going to come out to be as plus 5 meters per second squared. In this case, when I have a negative velocity, a positive acceleration is telling me that I'm slowing down. If my velocity is negative, a positive acceleration tells me I'm slowing down. Okay, so we kind of embedded a full new topic in this slide. Let's answer the question here before we move on. But what we discussed is very important, and we'll get back to it later. Is it possible for an object to have a positive velocity and a negative acceleration? Yes. That's the first case we described here, when the object is slowing down while moving in the positive direction. Is it possible for an object to have a negative velocity at the same time as it has a positive acceleration? Absolutely. That's the case we just discussed last. When it is slowing down in the negative direction, then it would have a positive acceleration. Now, this is the thing that you need to be very careful about. In our common day use, people have the misconception that a negative acceleration means slowing down. It's not the case. A negative acceleration is slowing down if my velocity is positive. If my velocity is negative, I need to have a positive velocity to slow down. A positive acceleration to slow down. What's key here is that the velocity and the acceleration are in opposite direction or opposite sign. When acceleration and velocity have the same sign, the same direction, I'm speeding up. When they have opposite signs, opposite direction, I'm slowing down. That's the key.